Good afternoon, everyone. This is Andrew at the Wyoming Dinosaur Center, and this is Fossil Friday. We're going to do something a little different this time, because instead of having a specific fossil to talk about, we're going to instead talk about something that's been in the news a lot lately, and I mean a lot. A lot of you might have heard of this new study that says it's shaken up the way we classify dinosaurs based on the structure of hips and all of that good stuff. So instead of going through our usual fossil, I'm going to try to simplify this idea and explain it in a way that I think we all can understand. And it's a good way to introduce you. In paleontology and geology, there's a way we like to try to explain things, and that is with this, what I've got right here, food. Good stuff. So as you can see, I've got a lot of gelatin right here, all different shapes and colors and all that good stuff. Now let's say we wanted to organize this jello in a specific way. Well, the easiest thing would be to go by color. So we've got orange jellos and green jellos, red jellos, and there's a random yellow jello in there. That would be the simplest way if we wanted to organize this. But then when you look a little bit closer, there's a lot going on with these jello pieces. Like for instance, look at the red jello. It's really ragged and broken up. Well, how do we account for that? There's lots of different little pieces inside some of these jellos. Some have more pieces, some have less pieces. Those are actual dinosaur fruit snacks. You gotta keep true to the form when you do this. So you can see there's a lot going on in here, and that makes it a lot harder to quantify all of this jello. Color might not work. Do we quantify them by how many pieces are in each of these jello things? Or how does that yellow one fit in there if we go by color? It's just completely out of the nowhere. So in order by analyzing this jello, we could get an idea of what's the best way to classify it. I might classify it one way, someone else might classify it another way. Now, is this all kind of arbitrary? Yeah, I mean, inevitably we're just going to end up eating this jello, so it doesn't really matter how you organize it. But when it comes to living organisms, classifying them is a very difficult, very complex thing. We call that phylogeny. That's the study of breaking organisms down based on the characteristics they share. So let's apply that to dinosaurs. Let me drop this jello. Questioning my eating habits after today's episode, but that's okay. So this is the dinosaur family tree, as we've known it since about 1842, when Richard Owen first coined the word dinosaur and started to describe them as a class. So if we go through this, off on this offset here, we have the Hypacrosaurs. That's the skeleton I have right here. These are the hadrosaurs and ornithopods, or we call the duck-billed dinosaurs. We have the ceratopsians, the horned dinosaurs, the armored dinosaurs, the sauropods, which are our personal favorite, the long-necked dinosaurs, and then on this side, we have the theropods, the big meat-eating animals. Now, we used to break these guys right down the middle, right about here, or show you with my magic pen. Right down the middle. That's where we broke it, swear to God. And we broke that based on the structure of the hips. We had lizard hip dinosaurs, the Saurischia, and bird hip dinosaurs, the Ornithischia. And you can probably guess where those names came from. This guy's hip looks like a reptile. This guy's hip looks like a bird. Now, is that arbitrary? Yes. Was there more to this identification and class division? Absolutely. But for the sake of argument today, we're going to break it down based on the hips. Lizard hipped, bird hipped. But that study got a little confusing. For instance, probably the best example of this is this skeleton right here. This is a scale model of Velociraptor. That hip is extremely bird-like. And Velociraptor is an extremely bird-like animal, and yet it's technically a lizard-hip dinosaur. So a bunch of scientists got together and were looking at these different criteria we use to phylogenetically divide dinosaurs up into these different classifications. And what they found was really exciting, and where they chose to look was even more exciting. See, going back to that jello, if we wanted to analyze that jello, probably the best thing to do would be to go back to the source. You don't want to analyze things in their final shape. Like, why would you compare a T-Rex and a Triceratops to see what their difference is, how closely we're related? You'd want to go back to find their common ancestors, see what's similar between them. So this group of scientists out of the UK didn't look at the final forms of dinosaurs. They went back to the origin of dinosaurs, right at the bottom of the family tree. These very primitive animals like Eoraptor and Herrerasaurus. These are some of the earliest dinosaurs from the late Jurassic period, roughly around 220 million years ago. Some say even earlier. And these guys have been so problematic for so long, we didn't know where to put them. They have a lot of features that look like theropods, but they have a lot of features that look like sauropods too. So what these guys did is looked at these traits and realized that a lot of the qualities that these animals share put them in groups closer together than we thought. To put that in plainer terms, Tyrannosaurus had a lot more in common with duckbills based on this new set of traits than it did with its previous closest ancestor, for this case, something like a Brachiosaurus. So that's what they did. They went back to the very origin of dinosaurs, found the traits that they shared, and then used that to reclassify the dinosaurs into new groups. So let's zoom back out, or rotate if we want. Yeah. Well, I'll use my toys down here for an example. So this, I've set them up in the order that they were before. If we were going to reclassify them, dinosaurs like Triceratops and Stegosaurus would be closer to the T-Rex than something like a Brachiosaurus would be. So this is how they've balanced out their new phylogeny of dinosaurs, by describing these characteristics. But now for the really important thing. This is really exciting. They got a lot of great data, lots of good stuff going on. Is this the new science? Do we have to throw out the dinosaur family tree like everyone says we're doing? It's possible, but we're not sure yet. They've got a fantastic study, but I can guarantee you right now, every scientist, every paleontologist who saw this study has it in their mind. I've got it in my mind ever since I heard about it. And that's the thing with science. We're always looking for the best answer. We may never know the exact right answers, just because, especially with fossils, the fossil record is so sparse, we might never find all the missing pieces, but we're always striving to find what the best answer is. These scientists out of the UK have found a new explanation that deserves a lot of scrutiny and looking at their evidence and seeing what they have to say, which is tremendously exciting. So that's what all science is. It's looking for the best answers. This is a new explanation. It answers a lot of unanswered questions, lots of great stuff, but I'm going a little long now. So you guys should know the drill by now. If you learned something from this, like our video. If you have questions or want to know what you think about what I've said today, comment. Share this video if there's anyone who you think might benefit from understanding this, because this is a really complex topic, even when it's right side up. And I guarantee you we're going to be looking into this a lot more in the future. And if any new updates come about, we'll be sure to let you know. So thank you all for tuning in. I hope this cleared up a lot of misconceptions or confusion you might have had over this subject. It's certainly very exciting. We'll be back to form next week with some fossils that might help explain this very convoluted topic, but we'll save that for next time. So until then, this is Andrew at the Wyoming Dinosaur Center, keeping your Friday fossiliferous.